Good morning, everybody. Thank you for joining our webinar today on innovative connections for mass timber. My name is Chris. I am the marketing account for Glass here in North America. If you have any questions about the presentation, we will answer them at the end. If you're on a computer, on the top bar, you should see a button for the Q&A, which you can click into and you can type your questions. If you're on a phone, on the bottom right-hand corner, you should see three dots that'll open up a similar menu that will also get you to the Q&A section. So without further ado, I will pass things over to our speaker for today, Neela.
Hello, everyone. Thank you for joining us today for the webinar, Innovative Connections for Mass Timber. My name is Nilu Hoshbach, and I'm a technical consultant at Rotoblast, and my area of expertise is wood connection design. So in this session, we'll explore innovative solutions in timber connection technology and their application in mass timber construction. Okay, to start with, let me introduce you to our company. Rotoblast. As you see, we are providing solutions for mass timber construction all around the world. We have 25 plus warehouses, and we're serving more than 100 countries with our team of engineers and sales force. In North America, we have more than 1,000 active clients, and we're serving 60 states and provinces in Canada and US with 2 warehouses. And also, if you want to know more about major projects we touched in North America, you can search our name in Wood Innovative Network website. All right. So this presentation begins with some foundational screw design concepts. The key parameters mentioned in NDS and some of the foundational concepts like ductility, minimum distances, and stiffness. We'll talk a little bit about the screws, and then we explored some of our high-performance solutions for a specific design, like Titan bracket, Alloy start, slot, radial, uplift. So wood connections are like major. We have 2 major categories. We have traditional and mechanical joiners. The traditional joineries are like utilize classic woodworking methods, like as you all know, mortise and tenon, and these joints gained popularity when CNC technology introduced, because the CNC technology allows for precise and effective fabrication of these connections. But however, they still cost way more than screws and plates. And also the other thing is when you create the like tenon or any like cut you put in the timber, you reduce the cross section of the beam. So for example, if you start with a 8x8 beam, the effective load-bearing capacity might be equal to a 6x6 beam. And also they require workload. Sometimes their workload increases exponentially, so you should be careful with the cost you end up with. In terms of mechanical connections, nails, bolts, and plates and screws, they all have been around. But the thing is, these connections mainly designed to deform, to resist lateral loads without making any splitting or fracturing in wood. So there is less fabrication in wood side and significant savings with metal connectors and screws. And yeah, they have been around for many years, but along the way, especially for CLT structures, they've been optimized, and still we use nails. We use nails with modern brackets, for CL2 plates, and also we use self-tapping fully threaded screws also to connecting CLT panels together. All right, so the typical connection systems are divided into 3 categories. First are shear connection systems. They are critical for transferring load between timber elements like walls and floors. And they are majorly used for, like, for example, here, as you see, it could be like a bracket system. You can also use screws for resisting shear loads in a CLT structure. We also have tensile connection systems like hold downs that you see here, and we use them to handle tensile forces, uplift forces, and they're essential for various mass timber systems. We also have biaxial connection systems. The main characteristic of this system is they consist of a steel plate, and also we have screws in these systems that are oriented in different directions, so they can resist force in different planes. And they provide a high strength performance. For example, this is our radial, this is a Titan bracket, and they are resisting loads in both tensile and shear. All right, so let's start with screws. And screws might seem simple, fundamental components, but by advancing engineering solutions, we've optimized our screws for diverse application. And let's dive into the world of screws. We have 5 major category screws mentioned in our catalog. We have partially threaded screws that allows components to be pulled together. We have, if you need more rigidity in the connection, you can use fully threaded screws. We also have fully threaded rods with some for hybrid systems. We have screws to attach insulation to facades. We have a steel to wood screws. And finally, we have screws that are suitable for outdoor applications like decks and pergola. Okay, so we looking at the screws from design standpoint today regarding NDS, and we talk about some of the major concepts. If you want to know more about the application standpoint, I will highly suggest you download our smart book for timber screws, which you learn more about the proper installation, type of screw head, screw tips, environmental concerns, moisture, fire, and wood corrosivity. And also, if you look, if you want to know how to find information on our website, for example, you type in VGS screws and the product page comes up. If you go at the bottom of the page, you see that there are technical data sheet available for USA, ICC evaluation report, for USA, for Canada, for other countries, and ICC evaluation report for USA, for Canada, and also, if necessary, CAD files and beam model. All right, so let's talk about design consideration for screws. So screws can be loaded in shear, tension, or combined. The screws are loaded in shear when the direction of load is perpendicular to the axis of the screw, and we can have two connecting two faces together, single shear or double shear, as you see here. And the screw also can be loaded in tension. Then we're going to deal with withdrawal of the screw, head pull through, and steel tensile strength of the steel. And okay, let's talk about the lateral, when the screw is loaded laterally. For calculation of lateral design values. NDS follows Johansson yield model. This is the same model that has been used in Eurocode 5. So according to Johansson yield model, there are five possible failure modes for wood dowel connection. And this is for the single shear. These are for double shear, and there are 1, 2, 3, 4, 3M, 3S, and 5. It depends on whether the crushing happens in wood. Crushing happens in wood in side member or main member, both side and main member, or the screw yields, either in main member, side member, or both. So you calculate the capacity in each its scenario, and it's the minimum capacity will be used for as the capacity of the screw. So I don't want to, I wanted to simplify this formulation. So basically the shear capacity of a screw comes down to the wood specific gravity, the dowel diameter, bearing length, and also the steel yielding strength and wood bearing strength. And here's a FYB, as you see, as wood bearing strength. And the way for wood bearing strength, as you see here, there is a table and formulations available in NDS, and their values come from the experimental test according to ASTM D5764. And here, as you see, the load is applied and the deformation is being recorded. Like we have a load displacement curve here, and the way it's been calculated, the slope of this curve is like offsetted by 5%, and that gives us the load-bearing strength of the dowel. So I mentioned this formulation is based on Johansson theory that has also been used in Eurocode. But we get many questions regarding why US values are different from European values. And the reason I explain this is that I want to just address that. As you see here, this is the wood bearing strength that we use according to US standard is taken from this part of the curve. But the wood bearing strength in Eurocode is based on the ultimate strength of the curve. And also, secondly, there is the Eurocode, in Eurocode, they add a value to the shear capacity considering rope effect. And that means after the screw is yielded, they account for the tensile strength of the wood. They add the tensile strength of the steel to their to the resistant value. So that's the reason the European values are higher in the case of laterally loaded screws. All right. So for the for screws in tension, we have withdrawal strength, which is proportional to the. This is the formulation that's been used in NDS. It's the withdrawal strength is proportional to the specific gravity of the wood and the dowel diameter. And the other thing is, if the screw is loaded at angle, we have a, sorry, excuse me. We have K alpha factor that should be multiplied by the capacity of a screw when it is loaded at perpendicular to grain. The alpha is when the screw is exactly inserted perpendicular to grain, the alpha is 1. But for example, you see this 0 angle, which is shown in this picture. The screw is inserted and loaded in parallel to grain direction in wood, and which decrease the capacity by 30% here. The other concept is head pull-through, which is not main of a concern when we have a fully threaded screw, but for partially threaded screws, if we didn't have any thread here, head pull-through plays an important role. And it also depends on the specific gravity of wood and the head diameter. And in the end, also, one of the most important factors for screw loading tension is the tensile capacity of a steel itself. So when you want to choose the tensile capacity of a screw, you have to find the minimum of the withdrawal, tensile of the steel, and the head pull-through when you look at the values in the catalog. And in the end, we have combined lateral and axial loads. For example, if you look at this rigging device, the screw has been loaded both in shear and withdrawal. And NDS gives a formulation for that, which is using the shear capacity, withdrawal capacity, and considering the angle between the load and the surface of the wood. Okay, here I want to just talk about a little bit about the difference of the partially threaded screws and fully threaded screws with this example here. So imagine we have the same wood thickness, and same wood species, and the same loading. Okay, if you want the connection to resist load F here, let's say we choose 4 partially threaded screws to resist the load here. That gives us 980 pounds of resistance. If we use only one fully threaded screw, which is the fully threaded screw here, at 45 incline, we get around 800 pounds of capacity. So as you see, the capacities are almost similar. But if you look at the stiffness of this system versus this system, the stiffness of the system is around 35 kips per inch. This one is almost like 5 times more. Even if you look at this curve, load displacement curve, this is for VGs for fully threaded screw. You see it starts with higher stiffness, and but for the partially threaded screws, we have lower stiffness, which none of them are better or worse. It all depends on the what we want in our design. And speaking of stiffness, the stiffness as you see here, for example, this is the load displacement curve for the wood based on the force here applied. And as you see here, the slope of the curve is the stiffness of the system. And for the wood, as you see, it breaks suddenly, which makes this behavior is a brittle behavior, and that's why steel connectors can strengthen the wood connection structures because they ensure the ductility of the system. Steel connectors designed correctly can strengthen and ensure the ductility, as I'm going to explain it here. For example, as you see here in this picture, it's a load displacement curve of the one dowel in the spruce, and as you see here, this is like wood itself. This is the load displacement curve for wood, but when we use it with like the connection in the ductility of the whole system changes. So it means that no matter how the system goes through the deformation, the strength remains the same. in like, this is another example regarding the ductility in connection. Let's consider a two-ring. It's like a chain made of steel rings and glass rings. And if the strength of the if we want the steel to yield first here, because if the strength of the steel is less than the glass, it yields, but it doesn't break. So the whole chain and it stays like the whole chain doesn't break. But if the strength of the steel is higher than the glass, the whole chain will break. So we want the steel to yield first here. The same concepts apply to connections. So that's why in our connection systems, we want the screw to yield first. You remember the 5 yield modes? We want the screw to yield first, so we want them to be in the failure mode 4 and 5 mainly. And as you see in this picture. And here's an example of a well-designed connection. Thanks to the union of these two different materials, it's possible to obtain significant ductility and with a high strength and stiffness here. So this is important, especially for when you want to like this, you want to dissipate energy. For example, when we have a sudden load and we don't want it just to I can say it allows the material connection to deform without like sudden failure, and you can accommodate large displacements and also at the same time maintaining the good load carrying capacity. All right, so to ensure the ductile behavior of the connection, it's also essential to follow the rules for in terms of minimum spacing and also minimum distances from the edge of the wood. So if you don't follow these rules, you may end up with like these are different types of failure, like splitting, plug shear, groove tear out, as you see, and the tensile failure. Especially when you install a screw and load it in the parallel to grain direction. It's really important to observe the minimum distances so you don't end up splitting like this. And also the minimum spacing is important because the wood tends to split from this area. So we developed also minimum distances for CLT connections with our new technology, which is as you see here, this is a standard tip of the screw. This is our pre-torn tip and also self-drilling tips. As you see, the minimum spacing A2 is the standard minimum spacing for the screws are like around 4D, and with the new pre-torn tip, it decreases to 3D, and also with self-drilling tip. And this means you can add more screws in less space or larger screws in smaller elements. That means like less cost and higher capacity in a less space for you. Okay, so I want to talk about the reinforcement of beam with fully threaded screws here. Wood is relatively weak in perpendicular to grain direction, as you can see it, for example, here when it's loaded in tensile, it works in tensile, for example, in this notch. It's the weakest of the values of the wood in this direction. So when we wanna make sure it doesn't break like that, so we use fully threaded screws to reinforce notches, and also wood is less strong in compression perpendicular to grain, which is this situation. So whenever we have a support, we want to put like we have less area here for the supporting the beam. You can use fully threaded screws to strengthen the area. Also, this tensile rupture can happen when you hang a small beam to a bigger beam. It creates tensile stresses perpendicular to grain in the bigger beam. So you can use fully threaded screws to strengthen that. And if you have a project, I'm not going through the details, but feel free to contact us if you have a project that you need help with. Yeah, fully threaded screws can be also used as hangers, I can say, connecting beams to beams or beam to posts. And the way we apply it is at 45-degree angle, and it should be fully threaded screw, because if you use partially threaded screw, for example, if you apply load in this direction, like downward first, this screw works in tension, but the other screw works in compression, and if there is no thread in this area, there is nothing that it can just hold on to and resist the compression. So we always make sure we use full thread screw for this. And also we provide jigs for 45-degree insertion angles. But please note that even with using jigs, wood sometimes tends to find the path of less resistance. And there is always like it's possible that screw can enter crooked, and it's normal for longer screws to have this behavior. So the deviation is okay to some extent, but we don't want it to deviate too much. And even if you use the jig or not, for longer screws, you might have this. All right, here's a summary of using fully threaded screws to connect beams to beams. So the advantages would be low cost, higher speed of installation, and also because it's hidden, it helps with the fire protection. And also, if you use the Evo coated screws, they work well in wet service condition, and it's minimally invasive. I can say you don't have to mill beams. The disadvantages is if you have a smaller beam, a smaller cross section, you may not get the resistance will be limited by the height and the thickness of the beams that are connected to each other. Okay. Okay, so this is a note regarding invisible notches that has not mentioned in any like a reference standards, but this actually happens when you have a smaller height connection that is attached to a bigger beam. It creates some sort of invisible notch, as you see here. And you can always, so I want to say, yeah, you know that this is the capacity of hanger is there. It had ICC marking, but to avoid any other problems regarding this invisible notches, yeah, you may want to use fully threaded screw to strengthen the wood fibers in this direction. All right, we covered the screws, and now let's look at our connection systems that also utilize screws. This is one of our innovative connections called disc flat, which utilizes the screws at like straight and different angles. And as you see, this is one of the usage of it. It can be used with different bolts, different length bolts for different situations. This is one like it's been used to connect the beam to the post. You can also and also it resists loads in it resists lateral loads, axial load, and also the downward forces. And and it's very versatile connection. It can be used on concrete, as you see here, or wood. For wood, if you want it to be hidden, you can use the mill. You can do the milling. Also, it can be used side by side to get larger capacity. Here's another picture that shows how we use disc flat for a steel to post connection and post to beam connection to resist axial load. Here we use it as a hanger to resist downward load, and axial load, and lateral load. All in all, because it's hidden, it helps with fire protection, and it had capacity in every direction. Also, you can use it with steel and concrete, and also if disassembly is important for you, it's easy to disassemble. But the disadvantages could be like you need to drill a hole, also requires milling, and capacities are limited compared to other hangers, and it needs a precise installation. All right, so regarding the connections in mass timber, there are many more connections. And there are hold downs, as you see, connecting wall to wall, panels to panels, for first floor, for intermediate floor. There are different solutions. For example, for the for the first floor, you can use even like we have 2D solutions like plates, WHT or Titan hold downs, and we also have innovative connection AluStart, which is basically continuous hold down. You can use also for intermediate floors. Also, you can use plates. Our innovative angle brackets, or even just screws. Yeah, we know that the world of mass timber construction is constantly growing, and these are some of the huge connectors, like 4 feet long plates. And of course, these are always custom made. But not in every project you can have custom plates. You don't want we at Rosablas develop special compact connectors just for provide off-the-shelf solutions. So we try to improve some of the off-the-shelf solutions. For example, you see here for our brackets, if you want to increase the capacity in the axial direction, you can use washers. And for this one, Titan N gives you capacities in every direction for shear, lateral, and axial. The other thing is we have used bigger diameter screws instead of nails. So this means less fastener to be fastened on the job site. And it also helps with increasing tensile capacity in the R1 direction, as you see here. This is also our Titan V brackets, and that we can use. This one has VG also, other than nails, it also incorporates VGZ fully threaded screws, and creates both tensile and shear capacities. One of the interesting thing about this Titan plate is, for example, if you you want to connect this wall to the end grain, so it's possible because we have a screws installed at angle. So you can use the capacity of these screws to use this exactly on the end grain, like a post here. Okay, so this picture shows, for example, our angle bracket is like around, the height is 5 inches, and it can be easily hidden in the floor built up. And also the other thing, if the wall thicknesses are different, you don't need to do a through bar here. You can use the angled screw to secure the whole system. All right, so we have many more connections we want to talk about. One is the for the connecting to the ground. You've seen this picture throughout the history. We always wanted to avoid contact between wood and the ground to avoid moisture going into the wood. So that's the way it's being used. They use the stone, like elevated wooden buildings. We have introduced this product called AluStart, which are aluminum profile in different sizes. They can you can install your CLT on top of the AluStart, and this creates a barrier between the concrete and the wood. And it's basically a continuous hold down, and it can resist downward loads, lateral shear loads, lateral loads. And for example, if you want to have an idea of the capacity for AluStart 100, we have compression capacity of 23,000 pounds per foot. And yeah, these are some of the values for that. In F4, F5, and like shear capacity would be around 2,700 pounds per foot. This is another picture of AluStart. As you see, you can use different patterns to get different capacities. So we use nail on timber side, and on the concrete side, any concrete anchor can be used. And for the alignment of the AluStart, we have the jigs, and also 90-degree jigs. And as you know, the concrete foundation never level. The tolerances are in centimeter, and AluStart can help with that to adjust the level. And then after adjustment, you can put formwork and pour grout to level under the AluStart. Here are some of the geometry for different AluStarts. It's like covers between wall thickness 3 inches to 7 inches. And there are fastening options available: mechanical anchors, expansion anchors, and chemical anchors. And based on the design, you can use like different spacing. And as you see here, AluStart do one more thing for you. You can just basically map out the whole structure, and then it really helps with the installation time, and budget-wise and cost-wise, it decreases the time of installation on the job site. Also, if you need it has capacities, but you can add more angle brackets or hold downs to increase the capacity. Here it shows that it can be cut in you can cut it easily on the job site, and also here it shows that it's been leveled, adjusted, and the formworks are here. They pour grout, and after pouring grout, you can take out the adjustment screws. All right, so let's talk about the connection to create rigidity between wall-to-wall panels or diaphragm floors that can resist in-plane shears. And this is our slot connector. It's one of Rosola's patents that is being used to create rigid platforms, like out of two multiple panels. So why we need such a connection? As you see here, the standard truck can is like approximately has a 9.6 feet height and 8 feet width. So obviously, if you have this CLT wall, you cannot if you design this wall, you cannot have it in the truck. So it should be cut to the components. And when this happens, this panel is not rigid as this one anymore. So how to connect those panels? So imagine if you're using hold downs on every panel, so you end up something like this, which is less rigid than a hole. But imagine if you have something that can weld these walls together, like this system. And this is why a slot has been created, and it's been tested on, as you see here, it's been tested on different CLT thicknesses, glulam and LVL. For example, for CLT, 3-layer CLT, you get around 10,000 pounds of shear load. And this is the characteristic shear load here. What we did, we ran a test campaign to see the differences between a rigid wall, shear wall, when we use a slot to connect them, and if we use half lap or spline joints. So the load was applied in forms of displacement in this direction, and here are the results of force displacement curve. And as you see here, this is the single panel load displacement curve for single panel, solid panel. As you see, with 4 slot connectors, we achieve something very close to the solid panel, while with hold downs we achieve way less than that. Also, with 2 slot connectors, it was less than that, but with 4 slots, we achieved something very close to that. We also thought these are the results of the test campaign I showed you regarding the comparison of a slot, half lap, and a spline joint. So if you assume the relative strength of a slot by 100%, half lap will be as effective as 50%, and the spline joint is around 75%. You also have to note that for the calculation, always the effective thickness that has been used for the calculation is only we use the thickness of the wood fibers that are perpendicular to the slot, and not the wood fibers. For example, in CLT we have different cross layers. We only account for the wood fibers that are perpendicular to the slot. And it's been, as you see in the picture, it's been used for wall panels, floor panels, and multi-story walls. Here's another picture. And you see how you can easily spot it from afar. So this is really, for inspection-wise, this is easier to inspect compared to spline joints. Here's another multi-story wall that uses slots. And okay, the other thing is, what if the panels are not closely exactly in front of each other? So you can use shims on the top and bottom just to adjust for this. All right. This product is called Radial. This is another new product of us, and you can use it with glulam, CLT, LVL, and it's very versatile. For example, here you see it's been connected to the steel. you can use it to connect wall to wall. You can use it as a hold down, as bracing, and it approximately has a capacity of 3,800 to 5,900 of ASD in tension, and also can resist around 2,400 to 3,000 pounds in shear. This product is called Ring, and it's a great solution for hybrid structures, and it can be, you can only mount, as you see here, you can mount it on one side of the panel, and it can be loaded in tension, shear, in plane and out of plane, because of the screws are like in different installed at different directions, angle directions. And also, if you see here, it already has a jig on it to make sure the screws are properly installed. And this is like the way this is the jig, built-in jig. This product is called Uplift, which is, I can say, basically it's a post base for the CLT wall. It also can resist loads in tension, compression, and shear. And you can use it for different purposes. You can use it to, like, as a temporary support. For example, here, as you see, they call the CLT beam, CLT panel, and use it as a temporary support. You can then later pour concrete in there, or maybe it can be used. It can be temporary or permanent. It depends on the usage that you need from it. And also, as you see here, there is a possibility of leveling with this shims, and it comes with different sizes. All right, I think, yeah, that was it for today, and thank you again for your time and for your attention. If you have any questions, you can put it in the Q&A, or also you can email us at eng.na@roseblast.com.
Awesome. Thank you, Nilu. As of right now, I don't see any questions in the chat, so I'm just going to reiterate that one more time. If you have any questions later today, tomorrow, next week, a month from now, please feel free to send an email to the email that you see in the bottom right-hand corner of the screen, eng.na@roseblast.com. I just want to thank you again for joining us today, and look forward to having you join us again in the future for future webinars. Next week, we have a guest speaker from Generate, talking about digital design tools for modern timber construction, and overviewing their software and how you can use it to help with your projects. And then on July 30th, our last webinar of July will be our Alumega pin connection for post-in beam systems webinar. So we hope that you enjoy the rest of your day and the rest of your week, and we will talk to you soon.